HPLC is a chromatographic technique and in which the HPLC column is the part where the actual separation happens. This video is related to the HPLC columns and their types. So HPLC system works on the principle of separation and then detection of the compound, and HPLC column is a core part of the chromatographic system, and in this column the separation happens. So the HPLC column is the core of the chromatographic system, and it is the part where the actual separation of the sample components occur. It is packed with stationary phase particles through which mobile phase flows, and separation is based on to the differential interaction between the stationary phase, mobile phase, sample components, and the structure of the HPLC column. As it is a chromatographic technique, the separation happens based on the different affinity of the compound or analyte with the stationary phase and the mobile phase. The material of the column is stainless steel, which can handle or withstand the high pressure, and generally the column length is 5 to 30 centimeter with inner diameter of 2 to 4.6 mm for the typical columns, and the packaging materials are like silica based particles, polymer based resins, or chemically bonded phases like C18, C8, and some others. So based on the chromatography, based on the method requirement for the analyte chemistry, we need to develop or we need to select the method and we need to select the column. If you select the wrong column, then the method will not be accurate and precise. Different type of columns are used like normal phase columns, reverse phase columns, ion exchange columns, size exclusion columns, and the chiral columns. Now we will see one by one. Normal phase columns, the stationary phase is polar, mobile phase is non-polar. Principle: polar compounds retain longer because polar compound will retain in the stationary phase which is polar. Applications for separation of the polar molecules, lipids, organic acids, and example of the normal phase column is silica column. Then reverse phase columns RP HPLC. Stationary phase is non-polar C18, C8, C4. Mobile phase is polar containing the water plus methanol or acetonitrile. Based on the principle that hydrophobic interactions happens, a non-polar compound retain longer. Most widely used type in the pharmaceutical analysis. Applications for the drugs, proteins, biological samples. Example is C18 column, which is a standard column used in the industry for separation of many of the compounds. It is also used for the simultaneous estimation. Then ion exchange columns. So stationary phase is charged resins, positive or negative charges may be there. Principle is separation based on the ionic interactions. Column types are cation exchange and anion exchange. Cation exchange attracts the positively charged ions and anion exchange attracts the negatively charged ions. Applications are amino acids, peptides, proteins, charged pharmaceutical compounds. So this is regarding the ion exchange columns. Then size exclusion columns. So stationary phase is porous beads. Principle is size based separation. Large molecules elute first, small molecules enter the pores and retain longer. So you might be thinking that the larger molecules may retain for longer time. So it is not like that. The small pores will take up the small molecules, and that's why small molecules will be retaining for a longer period. Applications for the proteins, polymers, and aggregation studies. Then chiral columns. So stationary phase is chiral selector like cyclodextrins, protein-based phases. Principal separation based onto the chiral molecules. Principle is separates the enantiomers based on the chiral interactions. Applications for the amino acids, chiral drug molecules, enantiomeric purity checks, and crucial for the pharmaceutical industry compliance. So, if your if your API or formulation is containing the chiral impurity, you need to have the chiral columns. HPLC columns differ based on the stationary phase, separation mechanism, and the application. Reverse phase HPLC is widely used technique in the pharmaceutical industry. Then specialized columns are available for the targeted separations like ion exchange, size exclusion, and chiral columns. This is the information for columns used in the HPLC. The columns selection should be based on the method, analyte chemistry, and the method development. So if you select the right column, then your method will be accurate and precise. Otherwise, you will have different problems and you cannot demonstrate the accuracy, specificity, and the precise nature for your method. Thank you for watching the video.